Hello, everyone, and welcome to this first episode of a series where I'm going to be teaching you Python. My name is Jonah, and I've been programming since about sixth grade. I'm really happy to sort of start guiding you through this programming journey. So, the first thing I want to overview is that I'm going to be using this website called Replit, replit.com, for sort of for teaching this class, and I recommend you use it as well. You can make an account, or you can just be anonymous and create a little scratchpad here, just because it's really easy. There's no setup for just writing some Python. You can also use other languages. So the first thing I want to note is that programming is a lot like, I guess, is essentially just writing instructions for your computer to follow. And you do that the same way that you write a book or a document. You can say, "Dear computer, I want you to make my bed and also make me breakfast." Now, of course, the computer doesn't actually understand what this means. You need to write it in a language that the computer understands, a programming language, we would call it. But how do we do that? That's essentially what I'm going to be teaching you, is how can you convert your thoughts, your sort of English words here, into a more basic syntax, is the word, for the computer to understand. So let's say we want to, when you start learning a new programming language, you want, the first thing that you often do is do what's called a hello world, which in this case simply means just displaying hello world in this little what's called a console right here, which is just basically a little window that can display text. So you might do that by saying display hello, but that's not super helpful. Or at least it doesn't. It's not helpful to the computer. The computer doesn't understand what this means. You'll see there's even red where it's saying, invalid syntax. It doesn't understand. But we're sort of part way there. We get this sort of idea that you have a verb, what would be called a function, that's going to take something, an argument, some sort of information, and it's going to do something with that. So the key word here for what we're trying to do is print. And you can see it's turned purple. And we're going to, we want to print something, we want to display something down here. So why don't we try that, print hello. And we're still, if we click run, we're going to get an error. And it's going to say, did you mean print hello? And with these sort of parentheses around it, and that's actually correct. We need to have, the print needs to give a hug to this hello, so to speak, in order for it to understand what we are wanting to do. Because for the print takes information, that's sort of the terminology, is that it's taking this hello, and it needs to be pointed to what you want to give it, what data is being input into it. So we have to put these parentheses so it can understand. And if we do this, we're still going to get an error. It says hello is not defined, and that's because the computer is trying to, there's this print box that something's going around in the background, and it's trying to display this hello, but it doesn't actually know what this hello is, because by default the computer is just going to be looking at each piece and trying to make a sense of it in terms of it has some sort of meaning. It's an instruction, I should say. But not everything that you're going to be giving to the computer is an instruction. Sometimes you're going to want to give it data, words, or numbers. And the way you do that is by, at least in this scenario, is you put quotation marks around anything that's text. And of course, because humans communicate with text, and if you use a computer, almost everything is done with text. So we have to put these quotation marks around the hello so the computer knows, okay, this isn't a special command for me, this is just something I should, this is just raw data. So there has to be a distinction there. So now, if we put print hello with with the hug, the parentheses, so that the print knows what we're giving it, and with the quotation marks, so we know that we're giving, so we know that there's going to be text. We get hello, and that's your first program. Congratulations. And I just want to make sure you realize that you can put anything in between these quotation marks. It doesn't matter. It can be symbols, numbers, anything like that, and it's going to display that verbatim. As you can see, it's exactly the same. Now, what if you want, here's an example. We're going to print hello 3 times. And that's sort of an interesting thing. If we run it, you get it 3 times because it reads the first line, okay, print hello. Second line, print hello. Third line, print hello. And we can even change this to 1, 2, 3, just so you get a sense of the order. There's like a linearity here, where it goes from top to bottom, left to right. Just like you would read a book. But let's go back to that example of hello. Now, what if we wanted to have it say cat? Now, we can go back and change each one of these, not class method, but cat. We can change each one of these to cat. But if we had like 50 or 10 of these, of this sort of message to be used in our program, whatever it's doing, it would take a lot of work to go back and change each one each time you want to change it, from hello to cat or whatever else, if you just feel like there's something that's more appropriate. So what we can do is define a variable, and it's exactly like a variable in math. You just express it the same way. You can say like message equals hello. So what it's essentially saying is message. Every single time you see message, what you should really put, what I'm really meaning is hello, these quotation marks. It's essentially saying, okay, we're sort of making it our own instruction, because before, remember when we put hello without quotation marks, it didn't understand what we were doing. Now if we were to call this hello, you would understand. But it doesn't matter what the variable is called. It can be called message, it can be called X, it can be called hello. I'm going to call it message. But all that matters is that it's holding some piece of information. That can be anything. In this case, we're giving it some text. What would be called a string data type, which is just a fancy way of saying like just text. So we can go here, print, and instead of cat with the quotation marks, we can put message. And it's very important to realize that message, in this case, because there are no quotation marks around it, the sort of the name of this variable does not have any meaning. The computer doesn't care what it is, and if we change it, it's not going to change what our message is. So there we go. We can get hello, and if we want to change this to have a good day. Have a good day. We'll click run each one of these changes, because the computer is saying, okay, I understand message equals have a good day. So every single time I see message, what you really want is have a good day. But if we do something like this, that's going to give us an error, because the message, the actual message portion is not actually, it says it cannot assign to literal. This is a piece of data. It isn't a name. Names, or a variable name, is always going to be just plain text. It's never, there's a straight quote. It's never going to have quotes around it. It can be equal to something with quotes, but it never has quotes around it. And also, you don't need the parentheses. I know I sometimes see people putting parentheses around their variable definitions, this piece of data that their variable is equal to, but you don't need to do that. Okay, And also I want to make a point of showing that the computer, if we were to put something like message, put it below there, the computer doesn't understand. You'll see it's outlined in red, and we click run, it says message is not defined. And that's just simply because the computer hasn't been told what message equals until the end. Now, you and I, we can quite clearly see that message is equal to have a good day, but the computer can't read ahead. It reads one line at a time. If you imagine putting your hand on the screen in front of the lines that you can't see, you put your, for example, essentially the computer, when it first starts reading your program, it just sees this. It doesn't see anything ahead of it. So if you imagine covering up everything below the first line, then second line, then third and fourth, blah, blah, blah. It's not going to be able to see those until, it's not going to, in this case, it's not going to be able to see the message is equal to have a good day until the very end. And the computer isn't smart enough to know to go back and, oh, actually I meant this. It's just going to fail right away. Now, what else can we do with variables? Now, so far I've introduced this data type called a string, or a piece of text with the quotes, and you can assign variables to that, like this is some text, but we can also give it numbers here. X can be equal to 5. X can be equal to 345.756. It doesn't matter. It can be equal to numbers. And just like you can do with pieces of text, you can go and you can print display. Look, print is hugging that X, it wants to display it, and we get that output. So variables we know can hold text, and they can also hold numbers. What's cool about with numbers is that you can do math with them. And this is what you might hear in your math class being called an expression. And it's called exactly the same thing in programming. You can do 5 plus 5, and it doesn't matter if there's spaces or not. So we can set a variable to be equal to 5 plus 5. And of course we're going to get 10. And because basically everything is an expression in programming, at least a lot of the time, usually what you're hugging, something like print is hugging, what a function or a command is hugging is usually an expression. So we can even do, okay, we have 5 plus 5, x is equal to 5 plus 5, which is 10. And we can actually go and do something similar. We can go we can do x divided by 2, and that's going to give us 5. Because what this is doing, here I'm going to introduce a new concept called a comment. If I put this little pound sign, everything after this pound sign is going to be ignored by the computer. So essentially what this is doing is it's taking this up here, which is essentially saying x is equal to 10. And then down here it's going to say print 10 divided by 2, which is essentially the same as saying print 5. So there's a lot of different layers of sort of abstractions here, but essentially it's printing 5, and you can see we get that result down here. Of course there's a decimal point, but we can sort of ignore that. So far what we've learned is that you can store pieces of data in variables like we do here, and we can have those, when we're dealing with numbers, we can even have those variables be equal to expressions like 5 plus 5, or even 5 times 5. And when we pass those those variables to something like print a function as an argument in those nice hugging parentheses, we can do more expressions. Like x divided by 2, which in this case, if we do 5 times 5, it's actually 25. And divided by 2, you can get 12.5. Now, one cool thing that you can do is of course you can also do exponents. So we can get that. Why don't I just print this by itself and get rid of this, so it's not confusing. Another reminder that everything beyond these this sort of this pound sign is going to be ignored by the computer. So we get 3,125. All right. And also you can have negative numbers, of course, like -5 works exactly like you would think. And if you multiply it by another negative number, you just get normal 5. So that works exactly the way you think. But now I'm going to introduce one sort of cool thing that you can do with parentheses. So far we've only seen parentheses being used with print, where you have these sort of hugging parentheses that go around any piece of data, like hello, or 5, or 2/7, 2 divided by 7. You can give print those that are surrounded by parentheses, but parentheses have another use. So let's take this 2 divided by 7. If we put that around parentheses, this is essentially the parentheses do essentially isolate this value. So whatever 2 divided by 7 is, it's going to be a fraction. I'm not exactly sure exactly what it's going to be. You can figure that out. It's going to be that really long decimal value. But 2 divided by 7. And then we can even do +1. And that's going to add 1 to it. Because you're essentially taking, if we do a little comment up here, it's essentially taking this value, whatever it is, and then adding this value to it. And the reason why you might want to do that, separate it with parentheses, is because if you do something like this, it might not be clear if you're doing 7 plus 1, but 2/8, like 2/7 plus 1, or not. Actually, you will get the same answer as if you don't include, as if you include those parentheses. They're essentially the same. If you have this and this, these are exactly the same, but it's just nice. And you can even have expressions with it. So if we take something like this, you have 2/7, this long fraction value, +1. You can even take this whole math problem, and if you put parentheses around it, and once again, spaces don't matter. I'm just using them to make this easier to understand. You can even do ×5. So what essentially this is saying is calculate 2/7, add 1, and then take that whole value, because it's separated with these parentheses, you can see they're highlighted, and multiply it by 5. So we get that. So you essentially can just do math a lot more clearly with this, which is very useful if you're going to be writing a program that's going to do any sort of complex calculations. Whether that be with like a game calculating score, it's really useful. And also, once again, I like to point out that this is an expression, and because it's an expression, you're doing some math, you can quite easily set it equal to a variable. This is perfectly acceptable. And if I put x in here, we're going to get the same value. And of course, you can use values. Let's see, 2 equals, well, let's say we want to multiply this by 2. Just because 2 occurs 2 times, you can say goggle, just coming up with a funny name, equal to 2. And we can put goggle and goggle. So now maybe this number that's repeated is somehow significant. We can easily change it to anything we want, whether it be a really big number or a really small number. It's going to all work out. So that's all I'm going to cover in this video. So why don't we quickly just go over what we've learned. I'm going to do a quick review. So first, we've learned that you can display text using this print function that gives a hug to some data, like hello, or 5, and it displays it. And we also learned that we can put store data, hello, whether it be text or numbers, or the result of a math problem, y, z. For example, 5 over 2. We can all store those in variables, which are just little boxes which, whenever they are used, will go back and look to the program to see where they've been declared, defined, and it'll use that proper value. And also I want to make a point of saying that you can redefine variables. You can say, x, actually I want to make x equal to world, or greetings. Or maybe you're making a program that's offered in different languages, you can say, bonjour, hello. And we can give it a little comment with that pound symbol that's telling the computer ignore everything after this is just a little bit of information, and say hello in French. So that's just a little note to us. And you can redefine variables. And finally, we learned about using parentheses in math. We can say x is equal to 5 times 2, and then we can put that itself in parentheses. Divided by 2. So 5 times 2 divided by 2. Actually, let's make that a 3, because otherwise it doesn't really matter if we're doing any math, because we're just going to get the same result. But so we have 5 times 2 divided by 3. And that whole math problem, the result of 5 times 2 divided by 3. And we're going to add 6 to that. So what we're essentially saying is, okay, take 5 times 2, which is 10. Divide that by 3, and then add that whole value to 6 and store it in x. All right, and why don't we see what that is? We get this nice decimal value. Well, that's all we have for today. I hope this, if you came in person and listened to me speak, hopefully this is a nice refresher and maybe explains some things better here rather than in person. Or if you didn't come in person, hopefully this gets you up to speed for next week. Anyway, thank you so much. See you later.